from DeVore, the Stat 231 textbook, DeVore's Probability and Statistics for Engineering, that deals with a old study about how to make television picture tubes, CRT tubes, if you will. It's a data set that has to do with use of different glasses and phosphors. There is involved in that data set 6 different types of tubes. And the response, the thing that is the output, or the variable that we're interested in optimizing or having good values for, is the current required to produce a standard brightness on a TV tube. And there are 6 different types of tube in that data set, and there are in fact 3 different tubes, or 3 tubes of each type. Are made and tested. Here is a table that has in it the raw data and some summary statistics. And if you'll notice, we're going to use notation Y with a pair of subscripts. This first subscript tells you which tube type we're talking about, I does, and the second subscript tells you which observation of a given type you have. So Yij is going to be the jth observation from group or set of conditions I. So that if we come down here, for example, and look at tubes of type 1, Y sub 1, 1 is the first observation of current requirement for tubes of type 1, that's 280. Y1, 2 is the second observation for tubes of that type. That observation is 290. Y13 is 285. Come down here to the last tube type 6. The first observation is 220. Second observation is 225. Third observation is 230. And the units of these observations are microamps. All units are microamps. And I've included in this table not only the raw data values but some summaries. I've included sample averages and sample variances for these 6 different types of tubes. For later reference, I'll also tell you that tube type 1 is actually tubes that were made with glass number 1 and phosphor 1. Tube type 2 is glass number 1, phosphor 2. Tube type 6 is glass number 2, phosphor number 3. That is, there's more structure here than just 1, 2, 3, 4, 5, and 6. But as I say, we've got to walk before we run, and so we're to begin with going to ignore that structure and just think of this as an experiment that was done to compare R equal to 6 different types of observations, R equal to 6 different ways of making television tubes. So this is the data set that we're going to work with here as an example in this module and a couple of subsequent modules. By now you've figured out that if one is going to do any statistical inference, is going to make confidence intervals, do hypothesis tests, make predictions, one needs some kind of a probability model. And so I want to introduce here the so-called one-way normal model that we will use as the basis of our inferences in